Hello, today we are solving problems and the topic of our lesson is conservation of momentum and energy. The problem is as follows. A bullet of mass 4 grams with a velocity of 650 meters per second hits a wooden bar of mass 95 grams. The bar can move on the surface without friction. Question. What is the velocity of the bullet as it leaves the bar if it is thin enough for the bullet to pass completely through it? And immediately after the bullet leaves the bar, its velocity is 23 meters per second. Is the final kinetic energy of this system greater than, less than, or equal to the initial kinetic energy? Check your answer to the previous part by calculating the initial and final kinetic energy. Now you and I must calculate the velocity of the bullet as it leaves this bar. Let's denote this velocity with the letter V3 because we will have a few more velocities before that. Now we know that the mass of the bullet is 4 grams. The velocity of the bullet, labeled V1, is 650 meters per second. The mass of the bar, which is M2, is 95 grams. And we know that the bar was standing still at the beginning of its motion, so the bullet hit a stationary bar. But after the bullet left the bar, it had a velocity of 23 meters per second. So let's now show in the figure that this task is happening and try to answer the first question, which is at what velocity the bullet will be traveling after it leaves this bar. So before the collision, we know that the bullet, mass M1, was traveling at velocity V1, and the bar was standing still, so mass M2, and the velocity is 0. So that's what we have before the interaction. And now after the interaction, and that is after the bullet has penetrated this bar, we get that the bar started moving at velocity V2. And the bullet also continued its motion but with velocity V3. Well, we can probably assume that this velocity will decrease because when the bullet passes through the bar, it is clear that the bullet will begin to slow down. And our task will be to determine this velocity again with the help of what? In this case, you and I realize that this situation will be described very well by the law of conservation of momentum, and for this purpose we have drawn the situation before and after this interaction. So the total momentum of the system before the impact, we can see, will be equal to the product of the mass of the bullet by the velocity of the bullet, so plus the momentum of the bar, which was 0 before the impact. The final impulse of the system is the sum of the impulses of these bodies after the interaction. The bullet has a velocity equal to V3. The bar has a velocity equal to V2. Now, if we're talking about the scalar form of this equation, then of course we need to project each vector onto the selected axis. Here it is convenient to choose an axis in the direction of motion of these bodies. Let it be the x-axis. And then in the direction of this motion, you and I project simply each vector. Taking into account that all vectors coincide with the given axis, then the projections of these vectors will all have a positive sign. Let's write down this equation. So M1 V1 equals M1 V3 plus M2 V2. We have this expression. Well, as we can see, the only unknown quantity in this expression is V3. All that's left is to calculate it. It's simple math. Or we express V3 based on the knowledge of the other quantities. We have the final formula. Let's put the value. Here I pay attention that in this formulation you cannot convert masses into kilograms because when we divide the numerator by the denominator, we see that the masses are reduced in dimension. Only velocity remains in dimensionality. So we can write everything down in grams and not convert it to sils. So 4 times 650, a minus. 95 times 23. And divide that by the mass of the bullet by 4 grams. After the calculations, we get the value of the bullet velocity of about 104 meters per second. It is generally expected that it will decrease, and we can see that it has decreased quite a bit. And more than 6 times the velocity has decreased. Now, the second question of this problem was to understand whether the final kinetic energy of this system is greater than, less than, or equal to the initial kinetic energy. That is, what can we say about the energy of this system in general? Given that the bullet has penetrated the bar, we realize that the process of penetration itself requires a certain amount of energy. Because it's a certain amount of destruction, which of course can't be converted back into energy. So some of the energy of the system will be lost, and the total kinetic energy must decrease. So our first assumption is that the energy will decrease. And now our task is to check it on calculations. And let's calculate the value of energy of the system before the impact and after the impact, and actually check our statement. So the kinetic energy of the system before impact, let's denote it like this, is the energy of the bullet. As we can see, only it was moving before the interaction. So let's calculate this energy. So the formula of kinetic energy we will remind you perfectly well. And here I remind you that when calculating the energy itself, of course, now mass will have to be converted into kilograms because we want to get the energy in joules. So let's put a value. So the mass of the bullet, 4 grams, or 4 times 10 to the minus third degree is a kilogram. Multiplied by 650 squared and divide by 2. So we get a value of 845 joules, which was the energy of the bullet before impact. Now let's calculate the value of the energy after the impact, and here we see it will be the sum of 2 kinetic energies. This is the energy of the bullet and the energy of the bar. So m2v2 squared in half plus m1 v3 squared in half. So m2 is the mass of the bar, 95 times 10 minus 3 kilograms. Its velocity is 23 meters per second squared, divided by 2, plus the mass of the bullet is 4 times 10 minus 3, and the velocity after impact, 104 we've calculated, also divided by 2. So now we have the values all put all, we get the energy at the end in joules. So we've got a value of 47 joules, which is the energy of motion of the system as a whole. So what we're saying is that in this case, the total energy of this system has become less, obviously, because against 47 joules, we had 845 at the beginning. And if we calculate the difference of these two values, that is, we take away from the initial kinetic energy the final energy. Energy, what do you and I end up with? We get some energy that this system has lost. Let's assume that this loss was due to the destruction of this system, that is, the bar itself inside, plus a certain amount of heat was released as the bullet traveled inside the bar. Let's calculate the total energy lost, and to do that we'll subtract from the final energy of this system. So that's 47 joules. Minus 845 joules. So that's minus 798 joules of the energy that was lost. The minus shows that it has decreased, of course. Thus, we have solved today the problem of collision of two bodies and considered it from the point of view of momentum and from the point of view of energy. Let me remind you again that this interaction must be studied in terms of the two laws in order to fully understand how the phenomenon occurs. This is my farewell to you, and I will see you in our next lessons. Goodbye.